linear, non-homogeneous, linear non-homo. Homo means linear non-homogeneous differential equation. DE means differential equation. Nth order with variable coefficients. Nth order with variable coefficients. Nth order with variable coefficients. Variable. So L of y. Here L of y equal to L of y power n. Y power n plus a1x. A1x. Y power n minus 2. Y power n minus 2. N minus 1. Plus a2x. A2x. Y power n minus 2. Y power n minus 2. Plus so on. Plus so on. So anx y. Anx y equal to b of x. B of x. I will write here. Equal to b of x. Equation number 1. Consider. Equation number 1. Here a1x. Here a1x, comma a2x, a2x, a1x, comma a2x, so on. Anx are real or complex? Are real and complex. Real and complex valued functions. Fn means Fn functions defined on some interval. Defined some interval. Define some interval. I subset R. If b of x equal to 0, if b of x equal to 0, b of x equal to 0, L of y equal to 0 is a homogeneous equation. Then L of y equal to 0 is homogeneous equation. Homo equation means homogeneous equation. Otherwise, L of y equal to OW means otherwise. L of y equal to b of x. L of y equal to. It's called non-homogeneous equation. It's called non-homogeneous equation. Non-homogeneous equation. Non-homogeneous equation. Right. So 11.2, page number 226. Page number 226. Page number 2. Second order homogeneous equation with variable coefficients, general solution. second order homogeneous equation, second order homogeneous equation. Second order homogeneous equation with variable coefficients. VC means variable coefficients. Variable coefficients. GS means general solution. So the general second order non-homogeneous linear differential equation with variable coefficients is obtained by taking n equal to 1. Put n equal to 2 in equation number 1. We obtain or we get second order means y double dash plus a1x plus a1x y dash a1x plus y dash a2x to y that equal to p of x. This is equation number 2. So a1x, a2x, and bx are the continuous functions depend on a closed interval I. Then if b of x equal to 0, then equation 2 reduces to the homogeneous. So equation 2 reduces to homogeneous equation. Homogeneous equation. Homogeneous equation. Y double dash plus a1x y dash a1x plus y dash plus a2xy equal to 0. Equation number 3. So to find a solution on homogeneous equation 2, it is normally necessary to consider its homogeneous equation 3 first, then solve y if y x c1 c2 is the general solution of 3 containing two arbitrary constants c1 c2 and the psi of p is a particular solution of equation 2. Here y of x comma c1 comma c2 is a general solution or complementary function. Next, here psi of p is particular solution or pi particular integration or ps particular solution. So then equation 2 general solution of y of x, then general solution of equation number 2. Equation 2 y of x equal to previously we discussed now y equal to y of c plus y of t, nothing but general solution y of x equal to complementary function plus particular integration. Complementary function plus particular integration. Y of x comma c1 comma c2 plus psi of p. Here. Next. Page number 228. Page number 228. Page number 228. Page number 228. Example 11.2.4. Example sum 11.2.4. Using this concept. Example, consider the equation. Consider the equation. Consider the equation. Consider the equation. Y double dash plus 1 by x y dash 1 by x y dash minus 1 by x square 1 by x square y that equal to 0, where x is greater than 0. Greater than 0 means positive. Actually, show that there is a solution of the form. Show that there is a solution of the form. There is a solution of the form. Solution of the form. X power r, comma r is a constant. Is constant. A constant. A constant. Find the two linear independent solution. Find the two linear independent solution. Solution. Independent solution. And write the general solution. And write the general solution. Right. Solution. Sorry. Given equation. Y double dash plus 1 by x y dash minus 1 by x square 1 by x square y that equal to 0, x is greater than 0. Right. Substituting y equal to x power r. Substituting y equal to x power r. Y equal to x power r. Then equation gets transformed from transformed equation. Transformed equation. Then transformed equation. Then transformed equation. R into r minus 1. R into r minus 1. X power r minus 1. Plus 1 by x. R into x power r minus 1. X power r minus 1. Minus 1 by x power r. 1 by x power r. into x power r equal to 0. That implies r into r minus 1 plus r minus 1 r minus 1 into x power r minus 2 power r minus 2 equal to 0. That implies r into two factors, r minus 1 plus r minus 1, that equal to 0. Simplify this one, r square minus r plus r minus 1 equal to 0. Plus r minus r get cancelled. R square minus 1 equal to 0. That implies r equal to plus or minus 1. R equal to plus or minus 1. So hence y equal to x power r minus 1, x power r power 1, and y equal to x power r2, That implies y equal to x and y equal to x power minus 1. That is nothing but 1 by x. Right, are two linear independent solutions. Two. LI means linear independent solutions. Linear independent solution. Solutions. Then general solution of this one is general solution of this one, y equal to c1x plus c2 by x. Here c1, c2 are arbitrary constants. c1 comma c1, c2 are arbitrary solutions, arbitrary constants. Arbitrary constants. So next concept is page number 229. Page number 229. 11.3. What is 11.3? Reduction of the order of the differential equation using a known solution. Consider the equation L of y equal to y double dash plus a1x into y dash plus a2x into y, that equal to 0. Consider equation number 1. Right. So is known who of its linear independent solution pi 1x and pi 2x are found. Let pi 1 of x and phi 2 of x. Phi 2 of x are both are linear Li, means linear independent solutions. Linear independent solutions. But there are no established methods available for finding the phi 1 and phi 2. However, if one of these two solutions, phi 1x, is found either by inspection or through some of the other device, then it is possible to determine the other solution phi 2, phi of 2. This method is popularly known as the reduction of the order of homogeneous equation using a known solution. You will now learn this method, which was developed by the 18th century mathematician Leonard Euler. So let phi 1x be the given non-zero solution of 1. Let phi 1x be the non-zero solution of 1. Non-zero solution of non-zero solution of equation number 1. Zero solution of 1. Then we know that C1 pi 1x is also a solution of constant C1. We replace C1 by unknown function V of x and determine V. So pi 2x, pi 2 of x equal to pi 2 of x. So V into pi 1 of x. Pi 1 of x. So similarly, pi 2x equal to pi 2x equal to V into pi 1x of x is other assumed solution. So pi 2 dash of x equal to assumed solution. Pi 2 of x equal to pi 2 dash of x equal to V into pi 1 dash of x. V pi 1 dash of x plus V dash pi 1 of x. Pi 1 of x. Similarly, and this is pi 1 of x. Printing mistake is there. Page number 229, you have to correct it. That is pi 1 of x, not pi 2, right? So pi 2 dash of x and pi 2 dash of x equal to V into pi 1 dash of x, pi 1 dash of x plus 2V dash pi 1 dash of x plus V double dash pi 1 of x. Pi 1 of x. Pi 1 of x. So here writing pi 1 of x, pi 2 dash of x, pi 1 dash of x, pi 2 dash of in the notation, and substituting these expression pi 2 dash and pi 2 dash in the equation 1, we obtain on rearranging the terms we get. Rearranging the terms we get V into pi 1 dash plus A1x pi 1 dash pi 1 dash plus A2x pi 1 A2x pi 1 plus V dash 2 pi of 1 plus A1 of x into pi 1 to pi 1 plus v double dash pi 1 equal to 0. Equation number 2. Equation number 2. Since pi 1 is a solution of 1, we know that pi 1 double dash a1x plus pi 1 dash plus a2x, pi 1 dash is 0. Hence, reduce the equation. 2 can be reduced by above properties. 2 can be reduced by properties or by conditions. V double dash pi 1 plus v dash 2 pi 1 dash plus a1x pi of 1 that equal to 0 or 0. V double dash by v dash that equal to minus 2 pi of 1 dash by pi 1 minus a1x Consider equation number 3. Right. Now, page number 230. Page number 230. 230. Page number 230. Page number 230. On integrating 3, we obtain on integrating equation number 3, we obtain or we get we obtain log v dash equal to minus 2 log pi 1 minus 2 log pi 1 2 log minus integration a1x dx hence v dash equal to 1 by pi 1 square 1 by pi 1 square e power minus integration a1x dx. So now integrating both sides. Again integrating both sides. Again integrating. BS means both sides. We obtain V equal to integration 1 by pi 1 square into e power minus integration a1x dx. So in other linear independent solution here, then phi 2x equal to phi 2x equal to v phi 1 f x, v phi 1 x, v phi 1 x, that equal to phi 1 f x, v phi 1 of x, phi 1 of x, e power minus integration a1x dx, a1x dx. So is the other linear independent solution of equation number 1. Is another linear independent, Li means linear independent solution of equation number 1. So using this concept, we'll solve one problem. That is page number 230. Page number 230. 230. Example 11.3.2. Example sum 11.3. If phi 1 of x equal to x square, if phi 1 of x, phi 1 of x equal to phi 1 of x equal to x square is a solution of is a solution of SOLN means solution of y double dash minus 2 by x square minus 2 by x square by x square into y, that equal to 0. So the value of x and the value of x is lies between 0 to infinity. This can be written as 0 less than x less than infinity. Then find general solution. And find GS means general solution. Yeah, general solution. So phi 1x here, yeah, phi 1 of x equal to x square is given. X square is given. Is a non-zero solution of the given interval. The other independent solution is the other independent solution. Other independent solution. Other independent solution is other independent solution is yes, this is most important theorem, most important problem for 10 marks question, right? This is a solution. Q2 means phi of 2 of x equal to phi of 2 of x equal to v into x square. V into x square. Since a1x equal to 0. Since a1 of x equal to 0 here. a1 of x equal to 0. That equal to v of x equal to v of x equal to v of x equal to what is the formula we have previously discussed, no? What is that? V of x equal to 1 by phi 1 square of x, phi 1 square of x into e power minus integration a1 of x into dx. This formula we need to apply now, right? So v of x equal to v of x 1 by x to the power of integration 1 by here pi 1 of x is x square. X square whole square is x to the power of 4, right? What I'm teaching, these are all only exam point of view important theorem. All the things which is not possible to teach in 1 hour now. Try to understand the students. Okay, that equal to into here integration 0. That means e power 0. E power 0 is 1. 1 dx. 1 dx. Anyhow, I will finish how much is possible within our last 10 minutes. I will give the rest important problems, right? That you solve means enough. All are 10 marks question only. This unit, big unit, this is 11th one, right? This integration, what we will get? X to the power of 4 minus 4 on simplification, on integration, we'll get 3x cube. 3x cube. How to get integration x power 4? Integration x power n formula using it, you will get that one. So hence phi 2 of x equal to phi 2 of x equal to minus 1 by 3x cube into phi 1x. Phi 1x means x square. This get cancelled. 1 will be there. That equal to minus 1 by 3x. Minus 1 by 3x. So x lies between 0 and infinity. 0 less than x less than infinity means the value of x lies between 0 to infinity meaning. So since constant multiple of solution is also here, since the constant multiple of a solution is also a solution. SYLN means solution. So we may choose phi 2 of x. We may choose phi 2 of x. We may choose phi 2 of x equal to 1 by x. So x square and 1 by x. So here x square means given solution and 1 by x are two linearly independent solution. Li means linearly independent solution of the given equation 1. Solution of given equation. Given solution. Given equation. Hence the general solution. Y equal to C1 x square plus C2 x 1 by x. Okay. Next 11.4. 11.4, page number 233. Page number 233. Most important for 10 marks. The Cauchy-Euler's equation. 11.4. 11.4. The Cauchy-Euler's equation. Cauchy-Euler's equation. Cauchy-Euler's equation. You can write CE. CE means Cauchy shortcut form. Abbreviated form. CE means shortcut form C. Cauchy-Euler's equation. Consider an nth order of linear non-homogeneous differential equation with variable coefficients of the specific form x power n d power n y divided by dx power n plus a1 x power n minus 1 d n minus 1 y divided by dx power n minus 1 plus so on plus an y that equal to f of x. Consider equation number 1. So where a1, a2, an are constant. Observe here that in this specific form, the index of the variable x and the order of the derivatives is the same in each of the terms of the equation. Such type or form of equations are called Cauchy-Euler's equation. To solve, we change the independent variable x to t by putting variable form, independent variable form. To solve the equation, we change the independent form. We change the independent form. Independent form. Change the independent form. From x to t. From x to t. X to t. X to t. By putting x equal to e power t. By putting x equal to e power t. So that t equal to log x. T equal to log x. dt by dx equal to 1 by x. And dt by dx equal to 1 by x. 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 So dy by dx equal to here dy by dx equal to dy by dx equal to dy by dx equal to 1 by x. 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 dy by dx equal to 1 by x, 1 by x, 1 by x, dy by dt, dy by dt. On simplification, we'll get second equation. Next, d square y by dx square, d square y by dx square, d square y by dx square can be written as d square y by dx square 1 by x square into 1 by x square into d square y by dt square, d square y by dt square minus dy by minus dy by dt, dy by dt using 2 and 3. And also we can convert like that also. This can be converted as d1 square, d1 square minus d1 means operator form. This is known as y, that equal to d1 we are taking common means d1 minus 1 into y. Continuing this process, we obtain monotonously. Page number 234. Page number, using this concept of 2 and 3, we solve a Cauchy-Euler equation. Page number 234, 234. Using important for 10 marks question. In this unit, all are 10 marks only, no small short answer type. So example, sum 11.4.1, solve. Easy means example sum. Solve x square d square y by dx square, d square y by dx square minus 2x minus 2x dy by dx, 2x dy by dx plus 2y equal to 4x cube equal to 4x cube. 4x. So solution. So by putting put x equal to e power t, that implies t equal to log x, t equal to log x, log x. So using 2 and 3 and using 2 and 3 equations, above equations or above formulas considered, above formulae, above formula considered. Okay, above formula, using the relations we obtain d square y by, we get d square y by dt square, d square y by dt square minus dy by dt, minus 2 dy by 2 dy by dt minus 2 of dy by dt, plus 2y equal to 4 e power 3t, 4 e power 3t. So on simply, or we can write d square y by dt square minus 3. This is minus 1 minus 2 equal to minus 3. minus 3 dy by dt plus 2y equal to 4 e power 3t e power 3t. So you can write operator form also. Huh? That differential equation we can write in operator form. What is that? D square minus 3d plus 2 3d plus 2 of y equal to 4 e power 3t. So this second order non-homogeneous differential equation with constant coefficients. So auxiliary equation. A means auxiliary equation. Auxiliary equation is m square minus 3m plus 2 that equal to 0. That implies factors are 1 comma 2. That m equal to 1 comma 2. M equal to we'll get m equal to, and simplify, split the middle term or use formula, we'll get m equal to 1 comma 2. Then complementary function or its general solution y of c equal to c1 e power t plus c2 e power 2t e power 2t e power 2t. So in particular integration, y of c is complementary function, y of p means particular integration, p equal to 1 by d square minus 3d plus 2 plus 2 plus 2 4 that equal to 4 e power 3t e power 3t power 3t e power 3t that equal to 2 e power 3t that equal to 2 e power 3t on simplification. So general solution. So general solution of one is general solution of above equation is complementary function plus particular integration. That equal to complementary function is c1 e power t plus c2 e power 2t plus 2 e power 3t e power 3t. So general solution of the given equation. Y equal to this. General solution is nothing but y equal to this thing. So all t are there. We have to convert into x form. In place of t, we need to substitute log x and simplification. We obtain general solution of given equation is given equation. General solution of given equation. Equation is y equal to c1x plus c2 x square plus 2x cube plus 2x cube. Right? Important for 10 marks question. Page number 237. Page number 237. So 11.5. Have to read 11.5. 5. Read the concept. Read the concept. Homework. Right. And solve the problem. Page number 238. Page number 238. Example 11.5.1. Example 11.5.1. Homework. Because this is also a 10 marks question. Most important parameters. Variation of parameter method. Next, page number 241. Page number 241. Concept is 11.6 concept. 6 concept. Then example sum 11.6.1. Example sum. Page number 42. Page number 240. Example sum 6.1. 6.1. Oh, 10 marks. This is also. Yes. Page number 244. Number 244. Page number 244. Concept. 11.7. Concept. Homework. Based upon this. Page number 245. Example sum. Example sum. 11.1. Most important for 10. Okay. These are how much is possible that we did. Do you have any doubts? Anybody? Hello? Yeah, any doubt?
No, sir.
Tell me. Okay, you don't have any doubts?
No, sir.
Then what I said, concepts and all are compulsory 1 10 marks question in theory. And sometimes 1 5 marks also they will give small question, right? Based upon concept. Okay, thank you very much. I'm leaving. We'll meet on 29th or 30 next Sunday, right?
Okay, sir.